This is part 2 of the 4-part video series on quadratic applications. This one's all about geometric examples. The length of a rectangular field is 2 meters greater than 3 times its width. The area of the field is 1,496 meters squared. What are the dimensions of the field? We're going to need to find what this width is and what this length is. So let's make those our variables. We're going to let W be the width. And we're going to let L, this handwritten L, be the length. And let's label it in our diagram, our width and our length. And there's an expression for length. It's related to the width. It says it's 2 meters greater than 3 times its width. So if I go 3 times its width, it is 2 greater. It also tells us that the area of this rectangle is 1,496 meters squared. Let's write that down. We've got the area of this rectangle is 1,496 meters squared. We know that the equation for area of a rectangle is length times width. We'll write that down. Right now we have an equation that has 2 variables in it. But luckily we have an equation that relates length and width, so we can actually replace this L with 3W plus 2 times W equals 1,496. Now that we just have one variable in this equation, we can solve for the W. Now we're going to want to expand out these brackets and bring everything to one side. Then we can either factor or use the quadratic formula to get what W is. So let's go ahead and do that. We've got W times 3W. That's going to give you 3W squared. And then we've got W times 2, which is 2W. And that's equal to 1,496. So let's bring this all over the one side, giving us 3W squared plus 2W minus 1,496 equals to 0. Now, you can go ahead and try and factor this. Because these numbers are pretty big, like this one here, and there isn't a greatest common factor that is in all 3 of these terms, so I'm just going to use the quadratic formula here. And to use the quadratic formula, I want to identify what A, B, and C are in this equation, and we know that this leading coefficient is the A value. The second term here is the B value with the W, and then the C value is this term by itself, negative 1,496. This is all going to be substituted into the quadratic formula, which in this case, instead of x, we're going to write w. Let's write that a little more pretty. We got w equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Let's put our variables in there instead. So b is 2. And then we've got B there is 2, and A is 3, C is negative 1,496. This A is 3. All right. Doing this in your calculator or in your head, whatever, you're going to arrive at eventually. You're going to get W is 22, or W equals negative 68 over 3. Now, it doesn't make sense to have a negative width. So this one answer that's negative is called an extraneous solution. So we're left with W, the positive version, which is W equals 22. And does that make sense? Well, we'll find out in a second. We got W, and then we could use our equation. So W equals 22. We know that length is going to be 3 times 22 plus 2. And 3 times 22 plus 2 is 68. And therefore, we can say the dimensions of this rectangle are 22 meters by 68 meters. And the reason why we put this little times here, I think that comes from the idea that if you go 22 times 68, 22 times 68 is the 1,496 meters. So it's a way of kind of knowing what the area is of that rectangle, which makes sense because that's what we wanted. And it kind of shows you what the length and width are. All right, so this one's done. We've answered the question, right? Asked for what are the dimensions of the field. Always double check, and we've done that. All right, on to the next one. In this example, we have the area of a triangle is 48 centimeters squared, and the altitude is 4 centimeters. Altitude is just the height of a triangle from its base. And it's saying that the altitude is 4 centimeters greater than the base. We want to find the length of this base down here. So we've got B for base. That's going to be something we're going to find. And then the altitude is this height of the triangle from the base. So we'll just draw a vertical line here. And this line always needs to be perpendicular to the base. And we'll call this the height of the triangle. And we're told that this height is 4 more than the base. So we'll write a little expression there for that. Okay. And given that we know that the area of the triangle is 48, we'll write that down. So from that piece, we have area of this triangle is 48 centimeters squared. All right, so that's what we got from that piece. And then this piece here, the altitude is 4 centimeters. That came right here. We have that piece. Let's try and use the equation for the area of a triangle, which is base times height divided by 2, to try and figure out what that length of that base is. What we can do now, because we have 2 variables in this equation, we want to use the relationship that we're told in the question to express this in a way that there's only 1 variable. So we could actually replace the h with a b plus 4. And that's divided by 2. And now it's just a matter of solving for b, which, as before, we are going to expand out brackets, simplify, and bring everything over to one side so that we can either factor or use a quadratic formula again. All right, so what I'm going to do first is actually bring this 2 by cross multiplying up to the other side here. So we've got 48 times 2, which is 96. And at the same time, I'm also going to expand out these brackets. So I end up getting b squared plus 4 times b equals 48 times 2, which is 96. And then I can now bring everything to one side. So I've got my b squared plus 4b minus 96 equals 0. All right, so let's continue on and figure out what the factors are for this. And this one's actually reasonable to factor. What we're going to do is think about what's going to add up to be 4 and multiply to be negative 96. With some trial and error, you'll get 12 and negative 8. Right? Because 12 plus negative 8 is 4, and 12 times negative 8 is negative 96. So we're good. Because this is a 1b squared, we can just set it up like this. We've got our b, and our b equals 0, and we just put in our results that we found in the pattern there, like that. And we end up getting our answer to b. B is negative 12, or b equals 8. It doesn't make sense to have a negative length, so we're left with our answer. The length of that base is going to be 8. And if this question also asked us to find the height as well, we could easily find that, right? Given that the base is 8, the height is just the base plus 4, which gives us 12. And let's just check this quickly. If I put the b value in and the h value into the expression, so I would have 8 times 12. Then I divide that by 2. That gives me 48. So this works. It's always great to check your work to make sure it's good. So it turns out this is correct. So we can say, let's answer the question. Go back to the question. What's it asking? It's not asking for the height, so don't bother even writing about the height. Just ask for the length of the base. So we will go, therefore the length of the base is 8, and this question's in centimeters, so make sure your answer is in centimeters. All right, on to the next example. Here we've got a photograph measuring 21 by 15 centimeters. What we're trying to do here is cut a strip of constant width off of this picture, so it maintains the same proportions, and that its area is reduced to 216 centimeters squared. We're trying to figure out what that width of this cut's going to be, so that we reduce it to this particular area here. So let's set our variables here. What are we trying to find? We're trying to find the width of the cut. So let's let x be the width of the cut. And on our diagram, let's label that in. So we've got this x is going to be this width, and it needs to be even around the entire picture, right? So let me just show you here. This here is my initial picture. All right, and what I'm doing is I'm cutting it off so it reduces, so that it's going to be this width now. This is what's going to be left of my picture. And maybe this is to fit into a frame or something while maintaining the same proportions of the standard picture. All right. So what we're going to need to do here is try and figure out a relationship and figure out some equations to figure out what this width is of this cut. What we do know is that the initial length is 21 centimeters. We've got that. And we know that the initial width is 15 centimeters. So we do know what the initial area is. Let's just kind of get that done. We have the area of the big rectangle here. This initial picture is length times width, and we know the length and width is 21 centimeters by 15 centimeters. And we can get that area if you like. That's going to be 21 times 15. So our initial area is 315 centimeters. And we'll see if this kind of helps us at all later on. And then let's figure out what this area of this small rectangle is. Once again, it's going to be length times width, but it's not 21 by 15 anymore. Now it's going to be, well, let's figure it out. Let's figure out what this new width is from here to here, right? We're trying to figure out what this width right here is. Well, we know that this entire thing is 15, right? So we've got 15 centimeters. But what we've done here is we've taken away, we've kind of removed this much, which is x. That's the width that we're trying to find, right? We've taken some off there and taken some off here. So what we should write is 15, right? 15 minus x. We took away x and we took away another x. So we took away 2 times x centimeters. Right? So that's going to be really important. Now we can write, we'll be able to write later this little expression here. And then the next part, we're trying to figure out what this length is. Well, we know that this entire length is 21, right? We know that is 21. All right, but then this smaller length, we've taken away this width and this width here. So we've taken away, once again, we've taken away 2x. Taken away x twice. And that's going to be our second value there. So now we can update our equation. We've got our length is 21 minus 2x, and our width is 15 minus 2x. All right, do we know what this small area is? We're actually given that, right? We're given in this question that our smaller area is 216 centimeters squared. So we now have an equation that we could solve and actually get what the x is. And as usual, what we're going to do is expand out these brackets, bring everything to one side, and either use the quadratic formula or factor to try and figure out what that x value is. Let's go ahead and start off by expanding these brackets out. So firstly, we're going to go 21 times 15. And that gives us 315. And then we're going to go 21 times the 2x, which gives, so minus 2x, which gives us 42 minus 42x. We're now going to go negative 2x times 15. And that's going to give negative 30x. And then finally, we're going to go negative 2x times negative 2x, which gives us 4x squared. All right, here we are. What I'm going to do is collect like terms and bring this 216 to the other side. So I'm going to be left with 0 here. And I'm going to have 315 minus this 216. I can do this, I can clean these two up here and combine them because they both have x in them. They become negative 72x. Because this is a 0 here, I kind of like having things on the left side, but so I can just rewrite it without changing the sign or anything. I'm able to write this. What's 315 minus 216? We get 99. Okay. In this question, I would just use a quadratic formula here. The numbers don't look very friendly, so let's go ahead and use a quadratic formula for this. Quadratic formula, we're going to need to identify what the A, B, and C are. A equals 4, B equals negative 72, and C is going to be 99. And quadratic formula states that x equals negative b plus or minus square root of b squared minus 4ac all over 2a. Replace these variables with the appropriate numbers. So we have negative 72 for b. And replace the a and the c values. So a is 4, c is 99, and we put it like this. If you do this in your calculator, you should eventually get x equals 1.5 or x equals 16.5. This is, they're both positive answers, so we can't just call the negative value the extraneous one. But one of these makes sense and one doesn't. And think about that on your own. Which one does not make sense here? Does it make sense to cut 1.5 off of this picture? I think that's reasonable. Like if my width and my length is 15 and 21, cutting 1.5 off of each side here does make sense. But to cut the other answer, to cut 16.5 centimeters off, doesn't make sense because my length here is 15. Cutting 16.5 is kind of impossible in the 15, and to cut 16.5 off 21 centimeters is going to make this picture really tiny as a result, right? So one makes sense, one doesn't. So you have to use a little bit of logic here. This is my one answer, and this one is extraneous. All right, so we can make our conclusion. Therefore, the the width of the cut is 1.5 centimeters. On to our final example. We have a rectangular construction site enclosed on 3 sides using 1,200 meters of fencing. The remaining side is formed by an existing wall. What dimensions enclose 80,000 meters squared of land? I've already kind of drawn my existing wall here. We're going to use 1,200 meters of fencing to enclose this thing. And we don't need to use fencing on this one wall, so we only need to use fencing for here, and here, and here. So we're saving off of using this existing wall, which is kind of nice. So our kind of area is going to be enclosed by this width and this length here. All right, so it's asking what dimensions enclose 80,000 meters squared of land. So what we're trying to do is find the length and the width. So we're given that the area of the enclosure is going to be 80,000 meters squared. We've got the area can be given by length times width because it's a rectangle. All right, but we have two variables here, so we need to kind of come up with some other expression that helps us out. We know how much fencing we have, right? So we know our fencing is going to be W plus L plus W, right? So that means that kind of my fencing that I have, so let's just say that kind of the amount of fencing, I'll just use P for perimeter, but it's not quite perimeter. It's going to be W plus L plus W, right? But let's clean this up a little bit and write it as 2W plus L. And we know what P is. We know P is 1200. That's how much fencing we have. So we know 2W plus L is going to give us 1200. And then what I can do here is I can solve for L. And so I get 1200 minus 2W equals L. Right? And let's just write this like this. So this is my expression here. So let's call this equation 1 and this equation 2. Let's substitute our equation we just created there into 1, and this allows us to have like an equation with only one variable in it. We're going to get 1200 minus 2W times W equals 80,000. Now what I can do is expand my brackets as usual, bring everything to one side, use a quadratic formula or a factor to get the answer. Let's go ahead and start that. So W times negative 2W is negative 2W squared. And then we've got W times 1200. So we got 1200W equals 80,000. Let's bring everything to one side. I'm going to bring everything to the right side because I like to have this with a positive. So when I bring it to the other side, it has a positive in it. So I'm going to get 2W squared. I'm going to bring the 1200 to the other side, so it becomes negative 1200W. And we have plus 80,000. All right. And because there's a 0 here, I can actually write it like this. Just because like a little nicer to have your variables on the left. Okay. Now, we have a greatest common factor of 2 in all of these. So what I can do is divide everything by 2, and that gives me W squared minus 600W plus 40,000 equals 0. And look, I basically went divide by 2, right? And that's what we get as a result. More manageable numbers. So feel free to try and factor this or use quadratic formula. I'm just going to write it down as a quadratic formula, and we end up getting W equals, so negative B, so we have negative of negative 600 plus or minus B squared minus 4AC, which gives me negative 600 squared minus 4 times 1 times 40,000 all over 2 times 1. And as a result of the quadratic formula, we get W is going to be either 76.4 or W is going to be 523.6. So there's actually 2 cases here, and both of these could be valid. We'll have to see here. Let's first go ahead and do 76.4, that version of it. And what we're going to do is, so case 1, we're going to go W equals 76.4, and our length, we have an expression for length right here. We could toss that in and get 1200 minus 2 times 76.4. That's going to give minus 2 times 76.4. We end up getting 1047.2. So in case 1, what we're trying to find here, the dimensions that close 8,000, we're going to have, therefore, dimensions are of the enclosure are 76.4, and what's this in meters squared? So meters by 1047.2 meters. Let's just check this by multiplying 1472.2 times the 76.4 will give almost, yeah, because of rounding error, it pretty much gives us 80,000. I got like 8,006. So be careful with how you round to get more accurate solutions. And then case 2, we're going to see if that works. We're going to do a width of 523.6 and use that in our equation. So we have 1200 minus 2 times that. All right, and we get, as a result, 1200 minus 2 times 523.6, 152.8. All right, and so this is kind of our second answer. So we have 76.4 meters by 1047.2, or we've got this 523.6 meters by 152.8. And let's just check if this makes sense by multiplying these together to see if the area makes sense. 523.6 times 152.8. That also gives us about 8,000. So I'm not really a fan of my numbers here, but maybe I made a mistake a little with rounding here, but do your best to just follow the process to get the answer. So this kind of concludes the different types of geometric examples you can find. Feel free to go ahead into part 3 of this series, which is money, and part 4, which are the physics examples. I hope this helped. Good luck.